So our first speaker today is Amjit, who is going to be speaking to us about Fuzzy Finder. Let's give a round of applause.
Thank you. Hey, everyone. Hello? OK. So we all know that Python is a powerful language. It's very succinct. It's the opposite of Java in terms of verbosity. I'm going to show you how you could implement a fuzzy finder in Python in just 10 lines of Python code. What's fuzzy finder? So if you have a modern editor like, I don't know, Sublime Text or Visual Studio Code, or if you have, if you don't have a modern editor, but you have a useful one like Vim, you probably have seen this fuzzy finder in action, which is, you start typing bits and pieces of your path, and then it somehow tries to find the file that you are interested in, and from the really long path. And that's what a fuzzy finder is. And why would you want to care about this? So fuzzy finder is an algorithm that you can use in any of the applications that you implement. For instance, I created PGCLI, and the fuzzy finder came out of that particular project, where it allows you to type in some random characters, not really random, but bits and pieces of a table name, and it'll automatically find the correct table name for your from the database. If you don't know what PGCLI is, it's a command line client for Postgres. That's immaterial for this talk, but just in case. So what do we need in order to do this? First of all, we need a collection of file names. So I have a collection over here. And the next thing we need is some bits and pieces of a character from this file name that we can use in order to filter this list. So here is DJM. And I'm trying to find the file name Django_migrations.py. I've highlighted the characters that actually match, and I've typed some, 2 characters from the beginning and 1 character somewhere in the middle. And the way the fuzzy match is going to work is you can simply take the user input, insert .* in between, and do a simple regular expression match. And if we do that, we immediately get these 2 file names narrowed down from the list that I originally showed. Now, how does this look in terms of a Python implementation? So first, we need the regular expression module, so we import that. And then let's create a function, because we're going to use this multiple times. And this takes in a user input, obviously, from the user, and then a collection that we're going to filter based on that. And like I said, we just need to insert a .* in between every single character in the user input. And that's exactly what this line is doing. Once I have that, I make a regular expression out of that, and then an empty dictionary to hold, or an empty list to hold the results that we're going to filter out of the collections. And for each item in the collection, we're going to apply the regular expression and see if it matches. And if it matches, then it is a possible candidate, and we append that to the results, and then we return the results. That's all it takes to implement a fuzzy match, right? Let's give that a shot. Let's see if that actually works. So I'm calling fuzzy finder. I pass in DJM and the collection, and I do get the results that I want. I'm ecstatic. I'm going to try another example here. Let's say MIG for trying to find migration.py. I do get a new list of items from that collection, and I see migrations.py in the list. But you'll notice that migrations.py is last in the list. If I were to select this from a menu, I have to press the down arrow 4 times in order to get to migrations.py. And the thing that is missing is the list that we filtered is not ranked in any particular order. And fuzzy match is supposed to find the file that you are interested in and bubble up the one that you wanted to actually select to the top. How can we do that? Well, the thing that we are interested here is here's where we stop thinking like a computer scientist and start thinking like a behavioral scientist. When a user starts typing in something, and what they're trying to do is, whatever the string that they have typed, the match should appear earlier in the result. How can we do this in Python? Well, we can do anything we want in Python, because Python has everything. So the match that we received from the regular expression is actually an object, and match has a starting location. And we can use that and append it as a tuple. And once the tuple is available, we can just sort that. And when we sort it, automatically the things that appear earlier in the result, earlier in the match, will bubble up to the top. It's close, but not exactly what we want. What's actually happening is when I try to match MIG, it's trying to match the longest item that is available. So if if a match is actually more compact, that should bubble up even higher that we want. Once again, Python comes to help us, so we add a second, another item.
I'm so sorry.
No worries. There it is. It's available as a library.
All right.
Just want to interject a really quick announcement. If you want another T-shirt of any size, we have a whole bunch downstairs, and we'd just love to get rid of them before the end of the day. So just come down anytime and grab some. Thank you.
Hi. So there's a programmer. He goes out to the grocery store. He has a list from his wife. It says, buy milk. If there's eggs, get it by a dozen. So he goes and he buys all this stuff and he comes back. And his wife looks at him and she says, why did you buy 13 gallons of milk? He said, they had eggs.
So next person who wants to do it for the next time. Okay, you want to go next time? Okay, so you're the next one. Thank you.
Are you ready here? Mike, we need the mic. Ladies and gentlemen, Raul Maldonado.
Hey everyone, hope you're doing well as we come to the end of PyBay2018. We just want to talk about a introduction to Flask and SQL Alchemy. Say you want to like spin up a server and work with the database. How would you go through that? Yeah, and those are logos, by the way, for Flask and then with SQL Alchemy. Motivations, again, you're creating a web framework using Flask rather than, say, something like the Django because you want some simplicity with your learning curve, right? And then you would like to, again, like create a database, like, oh, like how would I go through that, search the web, etc. Going on numerous Stack Overflow pages can be a nuisance, like at 3 a.m. at night. I'm pretty sure about that, and lose sleep. So yeah, those are motivations. And very quickly, some of you are familiar with Flask-SQL Alchemy library, which is basically Flask surrounding a wrapper around SQL Alchemy to provide you, user or Python developer, convenience. This is a discussion on Flask and SQL Alchemy. And this is not in-depth technical analysis of both of the libraries. And I'm going to just provide a quick light framework to show what how you can use Flask with SQL Alchemy. So here, Flask, the server is up. And then here we have a web page with an image and some HTML or text or HTML text. And then very quickly, I suck with this. Sorry. That's not that cool. Let's go. Let me just go to this endpoint. That's not the endpoint I wanted because it didn't auto populate. I'm almost there. Cool. Now, right here, I go to different web page, and then I go click into this submission box that was that I rendered from what you'll see from Flask. And from here, I query my information from my database. So let's quickly check that out. And yeah, go back. I'm on slide 3. OK, cool. So what happened in that like interaction is in the web browser, I went to a URL, Flask in the back end, queries the information in from /search in that submission box. I typed in Drake, and then queried that information in SQL Alchemy. It ran a SQL query in a Pythonic kind of way. Yeah, and here's just a kind of grand scheme of what just happened in the interaction of SQL Alchemy and querying from your database. Let's go into the code. Cool. Oh, shoot. OK, so what you notice here is you don't see SQL statements or a string containing SQL statements. You see, barely see. What you barely see is a Pythonic way to query information. And the way that's done is by creating a class, mapping that class in an abstract way through using a base in SQL Alchemy, and after once you do some little preparatory operations, which you'll see in the repo I'll provide send the link to later on. You see, you can make these query operations by commands or functions with SQL Alchemy, and then Flask. Popular lightweight Python framework, and what happened was the web server ran up from the client, and then from there, when we went to the URL, we did a GET request, and then and that just brought up the basic visual box and so forth you saw on the front end, and then when you went to the submission, you submitted, that was a post request, and then from it, and then that's where the operations happened within SQL Alchemy, kind of shown around in the middle of that the defined function, that section. There's a lot of operations happening in that in the Pythonic way. And very briefly, the way I created the route endpoint is by that decorator app.route. Thank you.
Thank you. All right. Our next speaker is called Lina Corredor. Maybe I said it right, maybe not, but she's going to be talking to us about pandas. And then our next lightning talk is going to be telling us about geopandas. So, a lot of joke.
And in the meantime, I'm going to tell you a really bad joke, but it's my favorite, so, whatever. Why are helium, curium, and barium called the medical elements? Because if you can't helium or curium, you barium.
Is there any other victims?
Can I start? Hi, everybody. My name's Lina Corredor, and today I'm going to be talking to you about data engineering experiment that I did for an ETL process. So what does data engineering mean in the data science spectrum? Basically, it's the starting phases of data science, which involves collecting data, moving and transforming your data. And it's especially important because you want to make sure the accuracy of your analysis is based on an accurate data set. And this helps to reduce the iterations that you have to do when you're doing your analysis. So I wanted to know how pandas compare to Python data structure when I'm doing a base case ETL process. I wanted to know if it's faster or slower. So what exactly is ETL? It's short for extract, transform, and load. And most companies use it for extracting data from their different business applications and putting into data warehouse or other systems. So the data set that I used was a vehicle collision data set. It spans about 2 years from 2015 to 2017. It's about 90 megabytes, and it's just big enough for me to differentiate between the difference between pandas and Python data structure. So for my process, basically, there are 4 stages. I extracted the data from a CSV file. I cleaned the data, basically removing duplicate rows, discarding data without key values. And I did a transformation on the data, which is a normalization to its normal form. And some of the operations I did was drop NA, concatenate, for loops. So the libraries I used were CSV for file import, SQL Alchemy for data modeling, PyMySQL for my SQL database. And here's an example of the data set. Each row is representing a collision, which has date, time, and location of the collision, as well as a vehicle type. So basically, I normalized it to 2 tables. And here's my result. So basically, you can see that pandas is faster than Python data structure. It's faster by 30 seconds, and that's mostly due to the loading stage to the MySQL database. And that's really helpful for me when I'm trying to choose between which tool I'm trying to use. And I also noticed that Python data structure is faster for the extracting and cleaning phase. So potentially, I might start using pandas and then switch to the other structure if I need it to be faster for a large set of data. And that's pretty much all. Thank you.
Thanks, Lena. And now a joke interlude. Yeah, grab it.
I'm a little bit desperate for the book, so here's the joke. Okay. So basically, documentation is very important, right, for all of us. When it's very good, and we can compare documentation is like SEC. When it's good, it's really, really good. And when it's not good, it's still better than nothing.
Okay. And now, Johannes.
Hi. I love spatial statistics, and I like maps. And I have a client that has a business-to-business model, and they really want to locate facilities near a bunch of hotels. So I have a problem here where I'd like to create market areas in dense clusters of hotels. And the data structure that I'm going to use is a GeoPandas data structure that differs from pandas in that you have a geometry column that will designate whether the data is point polygon or polyline. And then there's a coordinate reference system that is attached for that column. And then I'm going to use PySal, the Python spatial analysis toolkit, which computes inverse distance weight matrices, which are used for spatial autoregression or hotspot analysis. If you're interested in creating a completely open source spatial analysis toolkit, you don't have to go and buy software from Esri. You can actually use QGIS3, spin up a virtual environment, create a path file in your site packages, and point it to the QGIS core distribution package. Install PySal, GeoPandas, and Shapely, and now you don't ever have to use their software ever again. In this application, I have a data set of hotels, about 45,000, which are scraped from TripAdvisor. If you look at the hotels, it kind of looks like this. And I'm going to subset the hotels for hotels that have more than 200 rooms. I'm going to try to figure out where I should place market areas based off of number of hotel rooms and inverse distance weight on those hotel rooms from every single hotel across the continental US. So attributes that matter, XY coordinates and number of rooms per hotel. Scoring with inverse distance weighing on those room counts. And then fit a 120-mile radius market area around an initial seed distribution of centroids around core-based statistical areas defined by the US Census Bureau, and then iterate a statistic that looks at the center of mass of the hotels using room count and latitude and longitude, and repeat until convergence. This is what you get in the outputs. I'm going to have a hex grid that's going to have the hotspot scores calculated from this inverse distance weighing, and then 120-mile market areas. And then I'm going to classify the data using natural Jenks, and you can get that with Jenks Pi. PySal code kind of looks like this. You have to compute an inverse distance weights matrix. That's the PySal.weights method. And then you take that weights matrix along with some attribute that you're trying to apply inverse distance weighing to. And that's going to be the class G local out of PySal. And a little bit on GeoPandas. If you're going to use it, you should make sure to set your coordinate reference systems every time after you import your data and read it in as a geodata frame. And you can do anything that you normally would do with a pandas data frame, merge on indices, and more importantly, spatial join different geometries to one another if they share the same coordinate reference system. And this is the output I got for some other regions in the US. Brighter, closer to yellow is a better market area. Dallas, Orlando, Atlanta, Charleston, Las Vegas, Los Angeles, San Francisco. Thanks.
You have someone who wants to tell a joke? Okay.
Okay, thanks, Johannes. We have a joke taker, okay.
Whoops. There we go. So I have two. The first is, what is Bob Marley's favorite donut? What? The one with jam in. And the second one is, what do you call a magical dog? What? An abracalabrador.
Thanks.
Okay, thank you kindly. And now Sunil about serverless.
Hello all. So I know there is already talk on serverless before, I guess, in previous session. And this talk is more general kind of serverless. So my goal is to make you think about serverless after this talk. So let's see how successful it is. So I work with Chad right now. So if we see in serverless, so I'll just briefly go through that because we already know what serverless is. Mostly it's like you don't manage your own servers. It's sitting somewhere on the cloud. And it's only pay for runtime. You don't pay for storage. It's event-driven scaling. It's basically it auto-scales depending upon your traffic. And then it's a high availability and fault tolerance with enable in it. Now, what are the common uses of the serverless? So mostly it's the event source. So you basically have different kind of events. It could be data source event, storage, or some kind of API call also, where it basically trigger a function which could be Lambda or Google functions or Azure or whatever it is. And then you provide the services. Those services could be API calls, or it could be any of the image processing or any service you want to provide to the users or internally on your own company or something. So that's the main serverless user. So there are serverless framework which help you to build and configure your own serverless thing. So these are the prominent, like the famous, or what you say, famous frameworks which you use right now in the industry, which you see that. So why we use framework, right? Means what framework can I use? Just vendor CLI tools like the AWS CLI or Azure CLI kind of things. So there are two primary reasons. One is the configuration. You don't want to deal with all the configuration which need to deal with a specific vendor. Let's say AWS. You don't want to go and provide all the security rules and how to trigger those events kind of thing. So that's the one reason. Resource binding rules, and you don't want to do the environment things like the Davis days or kind of things. And the deployment, obviously, you don't want to deal with all the deployment part of it. If you quickly want to, that's the main of serverless, right? You just want to quickly deploy your code. So that's why you need the framework. So today I'm going to talk about serverless framework. It's named serverless. Maybe you heard about it. It's in our own company, we started using it, and we saw organically like different teams are using it, not only in Python code, but other codes. The main reasons are it's about the multiple language. So we had a different team. Someone use Node.js, some teams use Python, and some use Go. So we automatically started using serverless because it's kind of has a lot of good support. It has a big community support. It's a really big community. That was really kind of amazing for me to see. And it has an awesome CLI, which I will show you in a quick demo. And it had great plugin support. You'll find a lot of plugin actually. You can build your own plugin also. And it doesn't lock you in a specific one, so you can quickly change from AWS to any other vendor like GCP or Azure. And it's open source, obviously. So let me switch into the demo. I won't run the whole demo itself, but I will just show you what I did. So, this particular app, it's a simple app. It's a Flask app. What it does, it basically call the tutor API, get the PyBay tweets, the recent tweets. So there are, and this is the whole code actually. So if I open this thing, so it has, if you see over here, it has two. One is this URL where it renders all the tweets in this particular file, and the second is the API, which is basically nothing, just is that it's a JSON response. It gives you the JSON response for 5 tweets. So just assume that you have some kind of Flask app and you have some URLs or API on it, right? And then other than that, I have this requirement file where I install the Flask and all those things. So let's make it serverless, right? How do we make that serverless? So I'm not going to install everything because it might take time. We just have 5 minutes. And the thing which I did is, oh, man, I'm sorry. Something happened. Yeah. So here, what I did is basically the thing which I did, I just say npm install -g serverless. You basically install the serverless package on your system. And then I install these 2 requirements, which is the Whiskey server and Python requirements. What they do it quickly is basically it installs the requirement file, all the packages, and make your request to as a Whiskey request, basically. So that's it. And here, when I open this file now, to make it serverless, you make it this file serverless.yaml. Its name has the service. Then these are the 2 plugins which I just installed. And then we have this provider, and then the functions. So it accepts all the function and something. And then and then it deploy it. So it say SLS deploy, and you basically deploy it, and then you have these 2 URL. And that's really important because I did a lot of work on it, so I want to show this.
Thank you very much.
No. So before we go, so these are the 2 URLs basically.
Thank you. May I remind everyone, please retweet and share your tweet wisdom about Lightning Talks. We want to make a nice collage at the end, you know, with all the most beautiful memories of this weekend. Our next speaker is Dustin Ingram, but before that, there is one joke.
Does anyone have the last joke? Want to come up and?
Vikram, he's a good person. Good
person. So how many of you have heard about the Dunder Future module? So basically, it tells you about new features coming in future versions of Python and stuff. So if you go open your Python REPL, just import Dunder Future and try to import braces into it, what would you expect to see? Well, what you see is a syntax error, and it says not a chance.
Thank you.
And over to Dustin.
Here, I'll take that. Hey everybody. So hey, I'm Dustin. I'm a member of the Python Packaging Authority. I'm one of the maintainers of PyPI. I'm also a developer advocate at Google now, which means that I travel the world. Really excited to find out about new and interesting ways in which our products are broken. And I'm here to talk to you guys today about a PEP, but first let's talk about Python governance. Python governance is how we answer the question, how do we govern the language? How do we make changes to Python? So when Python was really young and new, we have BDFL. The creator of Python designated himself as the benevolent dictator for life. Dictator meaning he can do whatever he wants, and benevolent meaning that even though he can do whatever he wants, he's looking out for our best interests. And this is our BDFL. This is Guido van Rossum. And pretty soon, that didn't scale, right? So maybe Guido doesn't always have the best ideas, and we want to be able to make new changes to language comes from other people. So we have the PEP, the Python Enhancement Proposal Process. Can anybody name a PEP that they're familiar with? PEP8, yeah, that's the most popular one, Style Guide for Python Code. The author of PEP8, anyone? Guido van Rossum, of course. There's also PEP20, the Zen of Python. This is probably the shortest PEP. The author of that was Tim Peters. My favorite PEP is PEP566, Metadata for Software Packages 2.1. Author of this, here's me. So when I wrote that PEP, Guido himself did not review it. He doesn't care about metadata for software packages. Instead, we have BDFL delegates. These are people that derive their power to approve PEPs from the BDFL themselves, and they're concerned about specific areas of Python. And so the PEP process kind of looks like this. First, you write a draft. Then you hand it to the BDFL or BDFL delegate for acceptance. And then, if it's accepted, it gets implemented. So I want to talk to you guys about PEP 572. This is kind of a controversial PEP that you might have heard of. It's called assignment expressions. And what this does is it introduces a new syntax to Python. That is this, the colon equals. It has a name. I'm not going to tell you what it is. I like to call this the walrus operator because it kind of looks like a walrus lying on its side. And the goal of the PEP is this. So let's say we have this a line of Python code. We're creating a list with 3 fx, power 2, power 3. So you might look at this and say, that's a little inefficient. I'm calling f of x 3 times in a row, and I actually am redoing the same computation 3 times in a row. So maybe I want to pull it out. I want to assign that to a variable. But now we have another problem. We have 2 lines of code instead of 1 line of code. And some people might say, less code is better, right? We want to minimize diffs as much as possible. Some people might say, more efficiency is better. Instead, PEP 572 says, why not have both? It introduces this operator in a way that we can define a variable inside of an expression, like the creation of a list, and then we can reuse it in that expression. This looks a little weird, right? So the reception of this was not great. Most people really hate change, and there was a lot of feedback. A lot of feedback about PEP 572. One of the big complaints is backwards compatibility. It's not backwards compatible at all. So this is introduced in Python. It won't work in older versions of Python. Another problem is teachability. Like, what do we call this? We can't call it the walrus operator. We need a good name for it. And the last is attractiveness. Like, it just, to some people, really looked kind of ugly. So there were polls on Twitter, people asking serious questions about whether you liked it. There was also polls on Python mailing lists that also went on and on. And the results of that were that 76% disliked it, 16% had no opinion, and only 8% liked it. So of core developers, not a lot of people felt great about it. Tim Peters said the current proposal would have allowed a modest but clear improvement in quite a few bits of code. Barry Warsaw sort of noted that a lot of people were getting upset about this because it changes the syntax of the language, and people focus on that rather than understanding what it would do. Lukasz Lange said, dictators should dictate, and the BDFL should just accept it. And Guido said he had to stop reading all the mailing list threads so he wouldn't go insane. So after a lot of discussion, Guido went and accepted the PEP. And then he immediately did a transfer of power. He said that now that the PEP's done, he would like to remove himself entirely from the process, and he's going on a permanent vacation. All right, so you might have questions like, what does this mean for Python? Is this the PEP to end all PEPs, right? We don't have a BDFL anymore. How do we get anything done? I'm going to say to you that it's going to be okay. People are working on the governance problem. We're going to figure out how we're going to make changes to Python without Guido. Another question you might have is, will this actually become part of Python? And the answer to this is, yeah, probably. Maybe not till 3.8, or maybe even later. But it might actually happen, because it was accepted. And then you might say, but I don't like it. It's weird. And my answer to you is, all right, then just don't write it, right? No one's going to force you to use this syntax. And if someone is on your team is using it, you can work and convince them not to. Another question, is Guido coming back? Probably not. Python is 27 years old, and Guido is kind of like its parent. It's time for Python to sort of get out of the house and make it on its own. Another question is this going to happen again, right? Every time we're going to propose a change, is this going to keep happening? I'm going to say probably not. This PEP was kind of an outlier because it was a little bit weird, and it was syntax that everyone could focus on. But I don't really know. So many people use Python now, and for so many of those people, the language already feels kind of perfect the way it is. So this might be the new status quo for every time we try to make a change. Who knows? Thanks, everyone.
Thank you very much, Dustin. I actually don't really mind the walrus operator, but I like the name walrus. Yeah.
Okay, and now, Jeff, do we still have any free book?
No free stuff, no jokes.
Okay, because I arm myself with a list of crap jokes and
I can offer a beer to who says a joke. No one wants a beer.
Oh, we have a ticket.
There we are.
Okay, this is a bad Star Wars joke. What kind of parties do Star Wars bounty hunters throw? They throw Boba Fett's.
Thank you.
Okay,
Right.
now we have Benoit.
Hiver. Need to do my own introduction. So I'm not going to bore you to death because it's already the end of the day and it's Sunday, and I know you all are waiting for the result of the raffle. And actually, you don't need to win at the raffle. I have a free prize for all of you. And I think that's going to be the best prize of the conference, or at least I hope. Who in this audience wants to code faster? Okay, that's so I have actually a tool to do that. This tool is called kite.com, and so I can give you a little demo. So I took a file from actually Randall Hunt and his Twitter bot yesterday, and I can show you how that works. So basically, it gives you an autocomplete. So it gives you suggestions while you type. So even like me, you don't know how to code in Python, they suggest you some, supposedly, some good stuff. So here we go. And so it's powered by AI, and it ranks things not by alphabetical order, but by relevance, looking at your entire code base. So again, if you want, and I was saying it's maybe your best prize for the evening because it's free. So if you want to test it out, you just go on kite.com. And if you have a computer on your laptop here, you can directly go on the website and download it and install it. So here we go. We also have documentation because this machine learning algorithm is powered by data, obviously. And so you go on kite.com/Python, and you can, who wants to give me some function or something here that you want to look for? It's all, we basically aggregate not all the Python docs, but we cover more than 800 libraries, so it might be a good way to not have to go into the original documentation. It's all aggregated. They scrape basically all the doc strings, etc., and so it's always up to date. So who wants to give me something? Univer, how do you spell it? Or I remember the Beautiful Soup. Here we go. And so you can, it gives you the syntax, the signature, the code examples, etc. So if you don't want to install anything in your code editor, you can go directly in the docs. But if you want to have real-time suggestion, you install the tool in your code editor. And we support Atom, VS Code, PyCharm, Sublime, and many other code editors. So you might find the code editor your favorite one. So here you go. That was less than 5 minutes. We can have 3 jokes after that.
Thank you kindly, Bernard. And now we have Olivia. We're talking about small data.
One joke from the audience. Oh, here we are.
Yes.
What's your name? Corbin. All right. Please share your wisdom.
Oh, God. There's not much there. So I come from a chemistry background, so if anyone knows any sodium jokes, just let me know. Nah? Okay, that's all right. One more. You guys hear the one about the chemist reading the book on helium? He couldn't put it down. But he did learn that H2O is for water, H2O2 is hydrogen peroxide, but what's H2O4 for? Drinking.
Thank you. All right.
Thanks.
All right, Olivia Warren. Thank you.
Big data gets a lot of attention, and understandably so. With big data, we can employ powerful models that let us answer open-ended questions and automate decision-making. On the other end of the spectrum, however, I advocate that small data, while it doesn't have quite as loud of a roar, still has a pretty good bite. I say this because small data enables us to make timely decisions about specific questions, and while not every organization has big data, we all have small data. So in this talk, I'm going to explore how to best leverage small data to get value for your organization and answer questions. My name is Olivia Warren, and I work as a data scientist at Synthigo. We're a biotech startup in the genome engineering space, and we generate small data all the time when we're running experiments to experiment and figure out how do we best optimize our processes and our products. As a side note, we're also hiring, so if you like biology, automation, and coding in Python, drop us a line. So one question that I was approached with not too long ago was, we're deciding whether or not this new instrument that we purchased should be deployed in production. The instrument in question was a liquid handling robot, and its job was to take physical samples that we had and clean up impurities that we had before we ran quality control on them. And I came into the process after we had collected data. It was generated something like this. We had a batch of sample, which was split in half. Half of our samples went to our current instrument, which had been vetted. The other half went to this new instrument that we weren't sure if it was good enough to put in our actual factory yet. We ran the samples on these instruments. We measured the impurities after we'd processed them. And the goal was leverage this data to determine whether or not this instrument is at least as good at cleaning up those impurities as our current one is. Translating that into a statistical test, this seems like a pretty good case for an equivalence test where we're trying hard to disprove our null hypothesis, which is this new instrument is worse at cleaning these impurities than our current one. Backing up, small data is great because we have the luxury of visualizing it really easily. We can do this with Python and Seaborn, so in one line of code, we can generate a histogram with kernel density estimation. I see data scientists use this a lot. We can overlay different distributions, but there are two drawbacks that concern me most with histograms. The first is that non-data folks tend to have difficulty interpreting these. They're not as readily, people haven't seen these as much. And the other issue is that when you get larger than 3 groups on the same plot with histograms, it becomes really noisy and it's hard to get meaningful information out of the plot. So let's try this with a different Seaborn plot called a strip plot. With one line of code, we can group across different impurities, and we can color code and split out by condition. Here we have the new instrument in blue and our current one in green. Eyeballing the data alone, before we run any statistics, we can see that the new instrument is doing a pretty good job at cleaning up the impurities. The axis that we have on the left is the relative percent relative to our product spec, which is the maximum allowed amount of impurity that we have in our samples. So we can see here that smaller is better. And yeah, the new instrument looks pretty good. If we were to run a statistical test on this, it would agree with us. And great, we've doubled our production capacity. But we didn't collect data on 3 impurities, we collected data on 4. Let's check out that 4th one. Whoa. Okay, so there are a few things to notice here. The first thing is that our axis has jumped from a maximum value of 40% to 800%. That means that in this new graph, we're measuring up to 8 times the amount of allowable impurity that we have in our samples. That's a huge problem. Moreover, we've flipped the trend. The new instrument is performing worse than our current one is. So what's going on here? Twyman's law tells us that if a statistic looks interesting or unusual, it's probably wrong. So in this case, what's wrong with our setup? It could be that we genuinely contaminated this other batch of sample and that we physically have more of impurity D. But what's the other possibility? The other possibility is that our experiment is fundamentally flawed. If we think through the process with which we gather the data, we'll realize that at no point did we assess the variability in either one of the instruments. We don't know if that impurity D measure that we have is within the expected variance for that new instrument. It's possible that in multiple trials, we get wildly different measurements on that new instrument. So what went on here? The process flow that we undertook was collect data, approach data scientist, and ask for analysis. We should have flipped those first two. We should have designed our experiment first, determined the question we were going to ask, the appropriate data to answer that question, and then we should have pursued our analysis. And my takeaway here then is for non-data folks in the room, involve your data people as early as you can in the process. Get them in the room ideally when you're designing your experiment and you're figuring out what question you want to ask. For the data scientists in the room, I advocate that even in the face when it's scary, but when you don't have the data that you need to make a decision, push back and tell your stakeholders that you need more data, even if it's expensive, as it often is in biotech. Thank you so much for your time.
All right, we have our last lightning talk. Yeah. Up till now, we've done 29 lightning talks, and Al Zweigart is going to be completing our PyBay round of lightning talks today. He's going to speak about the last 50 years of programming education, if the monitor works. Yeah.
There we go. Okay.
Thank you.
Hello. Thank you. Yes, I'm Al Zweigart, and this is the last 50 years of programming education in 5 minutes. I write programming books. The target audience for these books are beginners and people who don't think of themselves as really technical. And a lot of times I'm teaching kids how to program. And so I think a lot about how we teach people how to code. And the reason I can go into the last 50 years of programming education is because it hasn't really changed that much in the last 50 years. I can cover this in 5 minutes. So back in the late 60s and early 70s, Seymour Papert and several other people created Logo turtles. You've probably seen this before. Python has a turtle module in its standard library. You can type this right now. Turtles are these objects on the screen. You can program them to move around, and they draw lines behind them, and you can make little pretty spirograph things like this. A lot of you probably have heard of the turtle module. What you might not know is that there is a turtle demo module in the Python standard library. You can type python-m turtle demo right now on all your laptops, and it has a great showcase of all these cool fractals and other programs and things. And turtles are great. They're great. In fact, that's probably why we've been reinventing them over and over again for the last half century. Even if you have a programming education tool that doesn't directly copy turtles, it's inheriting all the same concepts. I call these 2D grid worlds. So think of some programming education tools and ask yourself if this sounds familiar. They have one or more objects that are controlled by code, and they live in a 2D world with XY coordinates, and those coordinates are often discrete, but sometimes they can be continuous, and sometimes the world is also in 3D. It's essentially the same thing. This describes about every programming education tool I can think of. Let's go through some of these. Scratch, you have sprites on a 2D screen that you're programming. Lightbot is an old school Flash game that you program the path for this robot to solve these puzzles. Robocode, you have a 2D world, and you write Java code that controls autonomous tanks that shoot each other. Code Combat, pretty much the same thing, except instead of tanks, you have wizards and warriors and things like that. Vim Adventures, this doesn't teach programming. It teaches you how to use the Vim text editor, but it is still very much a 2D grid world. Factorio, this doesn't really teach programming, but so much systems level thinking and scaling large industrial designs. A lot of programmers really love this. It's a 2D grid world game. Zachtronics has a lot of programming themed games, and a lot of them are also 2D grid worlds. Computercraft, this is a mod that adds programmable robots, which are called turtles because it's still the same 2D grid world except in 3D Minecraft. And these are great. There's nothing wrong with 2D grid worlds and turtles, but I keep thinking, okay, I'm going to channel Raymond Hettinger. There's got to be a better way, or at least a different way, something we haven't thought of before, something that teaches actual programming concepts in a real programming language, not just a made-up scripting language. It's fun, it has a short feedback loop just like Logo Turtles, it has a gentle learning curve, and most importantly, it's not another 2D grid world. And so I've come up with some ideas, but I don't really find any of them that compelling. There's cryptography, this is manipulating strings and text. That's at least not a 2D grid world. Text adventure games, this is kind of fun, but it's very 1980s. Chatbots, that's kind of fun, but unless you know a lot of advanced computer science, they're going to be fairly mediocre. Algorithmic art, that's sort of like Turtle graphics, but maybe algorithmically generated music? I don't really know. I'm kind of proposing this as a question to all of you out there. Are there new paradigms for getting people interested in programming that's not just yet another 2D grid world or another Turtle knockoff? And if you have answers to this or you want to talk about this, here's my information that you can contact me by, and maybe we can make the next 50 years not like the last 50 years. Thank you very much.